Hi everyone, I hope you're well. So before you see this video, you should have done the starter worksheet, which is all about faults in circuits. So the first thing I'm going to do is go through those answers. So let's just go here. Ooh, apologies, where are we? Should have had this set up, apologies again. Right, so here we are. First one, what is the fault here? You have a circuit and it's meant to be a circuit for a torch. Presumably, you want to be able to switch this torch on and switch it off again. Unfortunately, the circuit you can see here will not let you do that. And that is because the circuit needs to have the switch in the normal circuit. Does that make sense? So currently, that switch will still allow current, even when it's open, current can still flow around here, which means that bulb will still be alight. So even when you try and switch it off, the bulb will still be alight. So your new circuit, can you see that switch is now in the loop? So when the switch is open, that bulb will not get any current flowing to it, and so will not light up. Number 2, another circuit for a torch. Now here you have 2 cells. Unfortunately, you know when you put batteries in a torch, ironically, or in anything, you need to make sure they're pointing the right way. You have a plus and you have a minus end, and they always need to point the right way. Can you see here, the long side is actually the plus, and the short side is the minus. And then here, if we go round the circuit, it goes minus and then plus. Now basically, when you put together a circuit, it should always go plus, minus, plus, minus. But here it goes plus, minus, minus, plus. Can you see? So they've basically put one of the cells in the wrong direction. So what they need to do, they can keep it as is, that's absolutely fine, but they just need to switch that cell around. So now it goes plus, minus, and they can have their bulb. Okay, hope that makes sense. Switching 2 lamps independently. So here you've got a circuit and you want to turn one light off and turn it off and turn the other light on and turn it off. Unfortunately, the way they've drawn it with them both in one loop of the circuit means that if you have one light on, you're going to have both of them on. And likewise, if you turn one off, you'll have both of them switched off. So if you want them to be able to switch on and off independently, you're going to want what's called a parallel circuit. Now, I know we haven't done these and we will spend a bit of time doing them later on, but I'm hoping you vaguely remember this from Key Stage 3. So here we've got what's called a parallel circuit, and you can see that I'd be able to switch one switch on and get the bulb light up without the other being affected. Okay, a lamp dimmer for model theatre. This is really the same idea as the top circuit, where they had the switch that wasn't actually in the circuit. Well, here you've got this thing, which if you remember from last lesson, is called a variable resistor. So variable resistor. And again, it really needs to be in your circuit if it's going to affect the current. So let's just put it in. Apologies about my dodgy drawing. Hopefully you're happy with what I'm doing. And there you go. Now it'll affect the brightness of your bulb. Okay, and the final circuit, lamps for a doll's house. So I'm looking at the circuit, doesn't look too bad, but I'm noticing that this time they've given me numbers. And you can see that the batteries are able to input 6 volts, whereas the light bulbs only take 1.5 volts each, so a total of 3 volts. That means basically it's going to be too much energy and that circuit will blow. So you either want to put some more bulbs in to even it out, or perhaps get rid of some of the cells so that you only have 3 volts going in and 3 volts going out. Okay, hopefully that makes sense. Let's go to today's lesson, which is on potential difference. So if you can please title and date. It's obviously not the 25th of September when you're seeing this, so whatever day it is when you see it, and then let's crack on. So our first bit of notes is a little bit more detail about voltage or potential difference. I know we made vague notes the other day, but I'm just going a little bit more into detail. So one side of a cell is positive and the other cell is negative. So you can see here, this is what I was talking about, with the long side being positive, the short side being negative. The way I remember it is I always draw a long side is P for positive, and the short side has a short one like N for negative. That's how I remember which one is which. This means that the electrons in a circuit are attracted to the positive end and repelled from the negative. They are given potential energy by the cell and forced to move. Potential difference measures how much energy per coulomb of charge the electrons carry. It is measured in volts. So if you can please pause the cell, take notes, and can you include this bit in your notes, please? Okay, hopefully everyone's had a chance to take their notes. The next bit is about voltmeters. Now, last lesson you said the voltmeter measures voltage. Hopefully you've got that circuit symbol in your book, but now you need to know how they fit into a circuit. So I'm going to get you to pause in a second and write this diagram. Write this diagram, draw this diagram, with the two notes on either end. Now, you may be wondering why there is the rapper Eminem in the corner. And that is because I always try and get people to remember the fact that a voltmeter must go in parallel to whatever component you're measuring. So here you've got a voltmeter trying to measure the potential difference of voltage across a bulb. And to remember that, because people always try and put it in the actual circuit, but you've got to put it in parallel with the circuit. I use the phrase from an Eminem song, which basically goes, round the outside, what? I won't carry on, it's highly embarrassing. I apologise for even doing that. But it is helpful to remember Eminem when you think about where a voltmeter must go. So please, as I say, if you have not done so, draw the diagram, add the notes. If you want to write the word Eminem, out of interest, the way he spells his name is Eminem. Yes, please feel free to add them into your notes if you want to. Okay, once you've done that, the next bit we are going to do is an equation. Let's just get rid of this, shall we? So I can draw V, voltage, or remember PD, potential difference, measured in volts, is energy. Now, energy here is shown with a W, and that is because energy can be swapped in with it. Something you came across in year 9, which is work done. So that's where the W came from. Don't pay too much attention to it. We'll always really refer to it as energy, but in case you wondered where the W came from. So energy is measured in joules, and Q there is charge, and again it's measured in coulombs. If you would like a triangle, it's W energy on the top and V times Q on the bottom. So again, please write this down if you have not done so. And then let's talk through a practice question. So, practice question. Please can you write out the entire question and the answer underneath. Sorry, got distracted. A flashlight battery has a total charge of 120 coulombs and has 480 joules of potential energy. What is the voltage of the cells? So voltage is energy divided by charge, W divided by Q, 480 divided by 120 equals 4 volts. Right, if you can please pause the video and have a go at these practice questions, and then I shall go through the answers in a moment. Okay, assuming everyone has had a go at those questions, let's go through answers. So I'm just going to change this. It's always, oh gosh, what am I doing? Far too thick to write with. Okay, so question number 1, a flashlight battery made with 2 AA cells, blah, blah, blah. Right, charge of 6,480 and 9,720 of energy. What's the voltage? Voltage is energy divided by charge, 9720 divided by 6480 equals 1.5. And it's voltage, so it's measured in volts. Number 2, during the time the light bulb was on, it converted 54,000 into energy, and it's plugged into a 120 volt outlet. What amount of charge has passed? Q is W over V, so 54,000 divided by 120 equals 450, and it's charged, so it's measured in coulombs. Number 3, a Van de Graaff dome has a voltage of 350 and a charge of 73 coulombs. How much energy does a charge have? W equals V times Q equals 350 times 73 is 25,550. And it's energy, so it's measured in joules. Number 4, 12 volts, 151,000 joules of energy. You're working out charge, so Q is W over V equals 151,000 divided by 12, which gives me an answer. Oh, it's a weird answer. 12583 and it's charge, so it's coulombs. And our final one, charge of 0.83, voltage of 480, working out energy, which is V times Q, which equals 0.83 times 480, which gives me an answer of 398.4, and it's energy, so it's joules. All right, thanks everyone. Please let me know if you have any issues.